So we're going to start relatively simple and build ourselves up to some pretty cool equations that we can actually solve using this uniqueness of the exponential. So remember, the goal with the uniqueness of the exponential is to have an exponential on the left and an exponential on the right that have the same base. That's really important. So we want to write both sides of the equation as an exponential with the same base. So in this first example that I have 2 to the x, the goal is to rewrite 16 as 2 to some power. So 16 could be written as 2 to the 4th power. That's what it's equal to. The uniqueness property of the exponential now says, because I have this equality of exponentials where the bases are the same, then the exponents must also be the same. And I can just set them equal to each other. In this case, x must equal 4. And that solves the equation that we've solved for x. Now, where things get a little bit trickier is in this next one. Don't write this down. If I try to do the exact same thing and say 27 is 9 to what power? Well, I know 9 to the first is 9. I know 9 to the second's 81. Somewhere in between them. Now, if you're really good with your rational exponents, you might know the answer to this. But I would rather show you a way that we don't have to be really good with our rational exponents, because rational exponents are kind of hard. So instead of writing the left side as 9 to a power, let's instead write it as 3 squared. So 9 is 3 squared, but when you raise a power to a power, you multiply the powers. And so really we can think about that as 3 to the 2x. And so that means on the right-hand side, I want to rewrite this as 3 to a power as well. So how do I rewrite 27 as 3 to a power? Well, that's actually easy. That's 3 cubed. The uniqueness property now tells me, since my bases are the same, my exponents must be the same as well. So 2x must be the same thing as 3. So now in order to solve this equation, I can divide both sides by 2 and get that x equals 3 halves for that example. Now you can obviously check your answer too. You can actually take 9 to the 3 halves power and make sure you get 27. Just keep in mind, if you're putting this into a calculator, that if you put in 9 to the 3 halves, that the calculator is going to do order of operations properly, which would be take the exponent and get an answer, then divide that answer by 2, which isn't what you intend. So if you did want to put this into a calculator, parentheses are important to say the 3 halves is the entire exponent, so it needs to be in parentheses.